Last class we discussed CU test for normally consolidated clay. Now come back to over consolidated there are just cases how the over consolidation comes into picture. Water table, clay deposit in bed of lake, then same if I extend it, this is clay deposit in the bed of lake and this is P0, then this is your deposition, then come back to here. This is your PC, then P0. Now, over consolidated clay. If I explain this over consolidated clay, this has been drawn A, B, C, D, 4 parts. First, let us imagine this clay deposit bed, this clay deposit in a bed of lake, where this water table is here, part A. Then over the period of time in that bed of lake, over the period of time there is more deposition. The layer has been increased, the deposition, suppose this is the clay layer and this is your deposition in a bed of lake. Then over the period of time this deposition has been increased to, this is your P0 is your overburden. Then it has been increased to consolidation pressure PC up to this. Then over the period of time again, due to some other reason there is an erosion, So, what will happen, this PC is still there, before erosion. That means this soil, particularly this soil exhibits this clay soil, this consolidation process starts, means consolidation process starts, all of a sudden what will happen, there is an erosion due to some other reason, this part has gone. So, due to this erosion, this our consolidation process is there in the soil, because in the present state the past means pre-consolidation pressure is not there, but this over consolidation means this consolidation has been over. So, this is a typical example where this clay layer is there in deposit in bed of lake. Now, if I understand with this graphically, if I can draw a graph with this, how this phenomenon of this over consolidation on the shear strength. Now, let us say these are the consolidation or virgin curve with this void ratio versus log P. So, virgin curves. So, this suppose say 10 years, then it is your 10 to the power square, 10 to the power cube, 10 to the power 4th, 10 to the power 5, means suppose this deposition virgin curve, this deposition of this clay over this clay, means there is a clay deposit in the bed of lake, over this clay there is a deposition, suppose it happens with 10 years, then maybe after 10 square years what is their deposition. So, deposition it increases. So, that means this overburden pressure it increases P0 to pre-consolidation pressure. So, that consolidation process starts. Now, suppose say this is my E0 initial void ratio of this clay. So, it starts with A, suppose within this 10 years it is A, where with correspondence to P0 overburden. Now, so due to creep or maybe due to erosion, so what will happen? It will drop down somewhere else here, say this is my B. Now, if I write it 0.1, so E0 which is at A of P0, then second part is your creep reduces the E0 or initial void ratio to E0 prime at point B. Then third point is your a sample removed would expand to C, it would expand to say C. Now, then during consolidation test, so recompression occur. C, D, E, F, that means C, D, it will go E and F. So, this will be your PC at E. Now, if I compare with this figure in terms of void ratio E versus log P, what will happen? Suppose this is my initial state, suppose this is a clay deposit in the bed of lake. So, initially what will happen? After certain time there is deposition. So, let us say this deposition is up to this 10 years, then once there is a deposition, because of overburden the clay deposit undergo consolidation. This is my first consolidation graph or virgin graph. Then again another 100 years, maybe 10 to the power 2 years or another 100 years, there is again deposition. So, because of that deposition again this consolidation curve, virgin curve looks like this, again another 100 years. So, it will continue this because of this consolidation process continue. So, it shifts towards your E versus log P towards the left. Now, suppose let us say this is my initial void ratio E0, this is the initial void ratio E0 of clay sample. So, soil is here. So, with this clay sample with this overburden pressure, P0 is overburden pressure. So, it intersect at point say E, one of this virgin curve, that is called 10 years time. Now, what will happen? Now, what will happen with this? So, it will due to creep suppose the void ratio will change from E0 to E0 prime. How it will change E0 to E0 prime? Over the period of time there are means depositions on the clay deposits. So, due to some other reason, suppose this is the initial layer, again deposit in 10 years, another 100 years deposition is there, another 100 year deposition is there. So, it will achieve up to a pre-consolidation pressure PC, then what will happen due to some other reason, the moment this soil sample will achieve a pre-consolidation pressure PC. So, consolidation process starts or overburden pressure P0 consolidation process starts. Once the consolidation process starts, then what will happen? Due to sudden erosion, that means soil will be taken out, or maybe water table, maybe this sea layer, this is the deposition in the sea bed of lake. What will happen? This water table goes down, it falls down, that means this overburden has lost, certain part of the overburden has lost. So, from initial void ratio to it will come back to the void ratio will change. Void ratio is your volume of voids by volume of solids. So, it will come back. So, this is your E0 prime because of your erosion, that is that produce your over consolidation. Now, the moment you take the soil sample, and take the soil sample from here to the laboratory to start your consolidation test, what will happen at these positions? Then once you put it in consolidation, so what will happen? It will be a recompression, it will start, it will expand from here to here, because the moment you take out the soil sample, this overburden has lost, whatever this overburden is there, it has lost. This is because of erosion. So, that is why the curve comes down from E0 to E0 prime. Then once you have taken soil sample, so what will happen? This overburden P0 will loss, means it will completely go away because of loss in overburden. So, this will be expand. So, then once you put it in consolidation, what will happen? This will become again recompression, it will continue up to E. So, that corresponding to your pre-consolidation pressure. So, now it will go C, D, E, F. This is what exactly this phenomenon over consolidated clay. Comparison with this example means a typical case, clay deposit in a bed of lake, how this deposition has increased over the period of time. All of a sudden water table comes down and erosion has lost. So, the soil already here clay deposit it has acted there, means already this clay deposit it is there, this consolidation process already previously started, that means over consolidation condition is there. So, once you have taken this clay sample, how it falls. Now, these things has to be relocated, you have to relocate effect of over consolidation on shear strength. Now, from consolidation curve you can show this effect of over consolidation on shear strength graph. So, let us draw this E versus log P diagram. Let us draw the E versus log P diagram. Then here it will be say E 0, then at point D it will be E 1. So, I draw this E versus log P. This is my virgin compression curve and this is the expansion curve and this is your recompression curve. What is the effect of over consolidation, particularly in case of shear strength? In case of shear strength, how this looks like in case of shear strength, what is that effect? Now, choose 2 points, one is D, other is your E. You can choose D, E means points in this, you can mark it. Just for example, I have taken for better understanding D and E. With D and E, draw lines, horizontal lines. First one is from D, I draw the horizontal line where it intercepts this virgin curve. This is AB, intercept virgin curve, that is your point 1, that is your point 1. Now, from E, draw horizontal line where it intercept virgin curve, that is your point 2. Basically, this is point 1 and this is point 2. Now, with D and E, extend this. So, to this shear strength, because this has been shear strength and P with this E versus log P, it has been plotted in the same scale. So, you extend it. Now, where it intercept 1 and 2 points at A and B of your virgin curve, it has been extended. Now, where it intercept in shear strength versus log P, this point, this is the intercept point, this is your 1, point 1. So, it intercepts say 1 dash. Now, similarly, point 2, so it intercept with this say 2 prime. With this 1 prime and 2 prime, draw horizontal lines parallel to your log P. So, this horizontal line, whatever you from E and D vertical lines extended, it will intercept at point, this point is your D dash and this point is your E dash. Like this, all the points from swelling to recompression, that you have to locate, that means your over consolidation points to be located in shear strength. Now, you will get, if I draw it, you will get a curve like this, then it will go. So, this is the point, this is the boundary line, this is the point, particularly it shows over consolidation. That means, in over consolidated clay, you will get a shear strength graph of like this. If I come back to earlier, so this is my PC. So, this is sigma is less than PC and this is sigma is greater than PC. That means, you will get a discontinuity at the point of pre-consolidation or over consolidation, you will get a discontinuity in shear strength curves. So, this is all about this effect of over consolidation on shear strength. Now, in CU we have already discussed two things, one is your UU and CU consolidated undrained case, where it has been used, particularly the test we will discuss in the next class. Now, last part is your CD. CD test is your consolidated drain test. Consolidated drain test means as I said earlier, for CU test there are two types of consolidation. You can say that isotropic condition where all round pressure is constant, that is your sigma 3, with all round pressure this consolidation going to happen. But other case is your anisotropic this is sigma 3 all round pressure. With this sigma 3 all round pressure, additional stress delta sigma 1 is applied, so that stress in sigma 3, stress in y or stress in x is not going to be same. So, this is a case of anisotropic. So, in consolidated drain test, the consolidation you have to do either the two conditions. So, truly it will reflect, particularly anisotropic conditions, it is recommended go for consolidation, so that it will reflect your condition of your field condition. Then once this consolidation is over, while shearing drainage valve was open. That means during shearing there is a volume change, during consolidation also there is a volume change. So, these are the this is CD test, means where we are going to apply in field, what for we are doing this UU and CU and CD. How UU, CU and CD, what for we are doing these states and how far it is related to our practical problems. This I am going to discuss over the maybe next class, how this UU, just in brief, what is the condition of UU. I will discuss many practical problems, unconsolidated, undrained, unconsolidated, undrained. The moment you say unconsolidated, undrained, suppose take an example of slope stability, slope construction. What will happen in slope construction? The soil from nearby pit has been taken and it has been compacted in stages. Once you start compacted in stages, because the consolidation process takes time, that means during construction there is no consolidation and also during construction there is no drainage. This case will simulate to your UU, unconsolidated, undrained. Now, the moment I say consolidated undrained means CU, after the construction you allow sometimes the slope, once the construction is there, maybe 2 years, 3 years, 5 years or 10 years, what will happen? The consolidation process starts. Here this layer particularly bottom, the consolidation process starts because of your overburden. Maybe for certain time, means consolidation is there, you want to that for a quick time, means not a longer period, what is the parameters. So, this will be your Cu. If I look at for a longer period, then you can go for a CD. So, these are we are going to discuss one by one, case by case problem. Suppose in case of footing, just this is I am discussing in brief. I will discuss next class in details. A footing is there, it is lying over sand as well as clay. So, the moment the construction of footing will occur, what will happen? Immediate effect is there, that means immediate settlement is going to happen. So, during construction, what test you are going to do? Is it UU, CU or CD? Then after consolidation, for a after construction for over a period of time, say 5 years, 10 years, what parameter you need to have so that this design can be done. So, these are all critical things, because this once you identify the problem and the parameters required to calculate your bearing capacity and settlement, then you need parameters C and phi. It may be C prime, phi prime, effective stress analysis, or it may be C and phi, total stress analysis. Depending upon the requirement. So, these things will be discussed later on. Now, we will start with a new one. What are the field tests or maybe site subsoil exploration or site investigation? Whatever we discussed, these are the two topics we discussed, because these are required in terms of particularly in this course. One is your consolidation, another is your shear strength. In consolidation, we discuss details how do you get it, CB and time factor. In shear strength, we discussed also UU, CU, CD in triaxial as well as direct shear test, as well as your unconfined compression test. These are the two particularly tests, consolidation and shear strength. These are required with simulate to your field conditions, means once the soil sample you will bring it from field, how and how far and how you are going to simulate in the lab, so that you will get required design parameters. Now, next part is your subsurface exploration. Selecting means why you need subsurface exploration. What is the need? What is the need that you want to do exploration below the ground? What is their need? Selecting type and depth of foundation. Second is your evaluating load bearing capacity. Third is your probable settlement. Fourth is your foundation problem. Like expansive soil, then collapsible soil, then your lateral earth pressure, then what are the construction method? Subsoil exploration is required to take soil sample below the ground, so that exactly you can test in the laboratory considering this site condition or field condition, so that you can get design parameter. So, what is that need? This need for subsoil exploration, that you need to have, you can get from subsoil exploration soil sample, from there you will get C, phi, this is shear strength parameter, and coefficient of consolidation, Cb and Cc. As I said, Cb is your time required to consolidate and Cc is your how much, means, and C and phi is your shear strength parameters. How these parameters are going to useful? These parameters are going to useful particularly selecting type and depth of foundation. What type of foundation you are supposed to choose and what is the depth, number 1. Number 2, how much load is going to take by this foundation. With the help of subsoil exploration, you can find it out these the parameters. With these parameters, you can get particularly how much load this footing can take. Then what is the probable settlement, or you can say expected settlement over a period, say maybe 5 year, 10 year, 20 year, over this design period. Then is there any foundation problem? Let us say, is there any foundation problem? That means, is there any expansive soil or collapsible soil? Then what is the lateral earth pressure? Lateral earth pressure, generally it is useful particularly retaining structures where one end is like water or other end is to retain soil mass, so that above the soil mass you can construct road, rail. Retaining wall means to retain the soil mass. What will happen in the retaining wall? It will apply lateral pressure. So, to find it out what is that lateral pressure acted, that also required for your subsoil exploration from these consolidation and shear strength parameters. Then how do you construct, particularly once you get shear strength parameters, what is the construction methodology you are going to do, that also you want to do it. So, these are the need. Because of these are our requirement. Because of these we go for subsurface exploration. From there the soil sample has been taken and the soil sample has been simulated to the field conditions. These are the test has been conducted. So, from this test you will get C, phi, Cb and Cc.